New York, restless, vertical, brilliant, along its avenues. 8 million stories unfurl each sunrise, woven together by ambition, steel, and stone. Beneath this metropolitan tapestry, granite of ancient continents lies thought to be immutable. But imagine, for a moment, a clandestine furnace awakening below, an upwelling of magma so vast that it rivals the fabled caldera of Yellowstone, a leviathan of heat pressing upward through cracked crust searching for release. Today we follow a strictly hypothetical path. What if a supervolcano erupted beneath New York City? Let us move through the science, the spectacle, and the sobering aftermath, guided only by evidence, precedent, and informed projection. A supervolcano is not merely a mountain that explodes. It is a colossal magma chamber capable of expelling at least 1,000 cubic kilometers of material. In reality, the crust below the eastern United States is geologically stable, buttressed by Precambrian bedrock. Yet a plume can in theory penetrate any lithosphere given geologic time. Visualize a bulb of molten rock 20 kilometers beneath Manhattan, swelling over centuries until the overlying crust arches like a pregnant drum. Surface motion sensors record uplift of 10 centimeters each year, while micro-earthquakes propagate along previously silent faults. Subway commuters feel faint tremors, seismographs chirp with unfamiliar urgency. In February of our imagined year, Central Park's lawns bulge by half a meter. Reservoir walls crack microscopically, and radon emissions triple in basements along Madison Avenue. Heli surveys discover anomalous warmth venting through storm drain gratings, as though the metropolis itself were exhaling. Public briefings invoke measured language. No immediate danger, but heightened vigilance. Yet satellite thermal imagery unmistakably sketches a blooming red ellipse beneath the city, where Broadway glitters each night. Geology now whispers of burial. At 7:18 on a windless June morning, an earthquake of magnitude 7.6 fractures the crust directly below Times Square. For 30 terrifying seconds, skyscrapers sway like masted ships, canyon streets funnel shockwaves skyward, glass cascades from facades, and the great bridges undulate yet endure. Subterranean pipes burst, sending superheated steam jetting through fissures in asphalt. Emergency sirens weave with the building groan of evacuating turbines atop tower roofs. Then comes silence, pregnant and absolute, only for 7 minutes. At 7:25 the ground fails. From beneath Midtown erupts a roiling plume of incandescent ash, pumice, and volcanic gas, the eruption column. It rockets 60 kilometers into the stratosphere within 15 minutes, dwarfing city spires, painting the dawn a baleful crimson. Shockwaves race outward faster than sound, rattling window panes from Philadelphia to Boston. This column is the volcano's exhalation, a thermal engine lofting sulfur dioxide and ash high above weather systems. Within its turbulent throat, lightning sears in violet forks, each bolt more powerful than any storm-born cousin. The skyline is remade in silhouette against a churning, thunderous tower of mineral dust. There is beneath the column a far deadlier force, pyroclastic density currents, ground-hugging avalanches of gas and pulverized lava, hotter than 800 Sug, and traveling hundreds of kilometers per hour. They surge radially from the collapsing column's base, flooding subway tunnels, snuffing oxygen in seconds. Brooklyn Heights is overrun in 4 minutes, Newark Airport in 7. Concrete crumbles, steel softens. The once raucous harbor falls mutely still as water boils and steam pillars join the murk. Out to 25 kilometers, everything combustible ignites. Beyond that, scorching ash thickens the air, choking lungs and engines alike. Venturing further, the stratospheric plume releases its burden to the winds. Prevailing westerlies spread ash across the Atlantic seaboard. Within 2 hours, 3 centimeters blanket Providence, Rhode Island, over 10 times the accumulation that once paralyzed European aviation during Ijafjalajökull. Ash is no mere dust. Shards of volcanic glass infiltrate machinery, abrade jet turbines, scour alveoli. Airports close nationwide. Power stations trip offline as clogged intake filters starve turbines. Solar panels dim beneath gray snow. By nightfall, Baltimore streets lie hushed under 10 centimeters of silt that squeaks beneath boot heels. Evacuation of an island metropolis with 1 hour's notice is impossible. Casualty estimates rival history's darkest chapters. Several million within the kill radius, many more imperiled by roof collapses from wet ashfall in neighboring states. Field hospitals sprout in stadiums from Pittsburgh to Richmond, Respiratory ailments overwhelm ventilator stockpiles. Strategic reserves of fuel and food, formerly calibrated for hurricanes, prove paltry. Interstate arteries grind as vehicles choke on abrasive ash, radiator fins clogging. Military convoys deploy but progress slowly behind bulldozers clearing pumice drifts. New York's financial heartbeat halts. Data centers in low-lying New Jersey sit under meters of volcanic debris. Fiber optic lines melt within conduits. Trading algorithms starved of latency do not simply slow, they crash. Global markets convulse at the sudden silence of Wall Street. Insurance liabilities, already spiraling from climate disasters, confront an unfathomable line. Item losses due to urban super-eruption. Reinsurers freeze, liquidity evaporates. Within 48 hours, international indices shed a quarter of their value. The steepest decline on record, not from sentiment but from infrastructural severance. A super-eruption launches hundreds of millions of tons of sulfur dioxide into the stratosphere. There it reacts with water vapor to form sulfuric acid aerosols, bright particles, reflecting solar radiation back into space. Earth's albedo jumps. Sunlight weakens. Historical analogs. Tambora 1815. Toba, approximately 74,000 BP. Herald of volcanic winter. Global average temperatures dip by 3 to 5 degrees Celsius over the ensuing 18 months. Shortened growing seasons spell disaster for agriculture. Corn Belt harvests fall by 40%. Rice yields in Southeast Asia plummet. Pastures in Australia wither beneath frosty summers. Oceanic circulation feels the chill. Sea ice expands, altering habitats from krill nurseries to coral reefs. Weather patterns shift, conjuring multi-year drought in some latitudes, deluge in others. Human migration intensifies as breadbaskets fail. Closer to ground zero, ash hardens like weak concrete when rained upon. Sewer networks clog, water treatment plants fail. Without functioning pumps, Manhattan's sub-basements flood with caustic ash, slurry that corrodes foundations. Steel I-beams enshrouded in pyroclastic material cool unevenly, warping into tortured geometry. Electric grids falter under the double weight of line breakage and surging demand for heat in the volcanic winter. Transformers short when insulators accumulate conductive dust. Emergency crews, themselves exhausted, operate within respirator-clad rotations. New York's harbor once channeled a tenth of the United States container traffic. Its sudden obliteration forces rerouting to Gulf and Pacific ports already strained. Pharmaceuticals once warehoused in New Jersey freeze or spoil. Critical ingredients sourced from Europe and unloaded at Red Hook lie entombed beneath meters of tephra. As the Hudson rail tunnels collapse, time-sensitive cargo, radioisotopes for medical imaging, reagents for vaccine manufacture, runs scarce, prices soar. Nations pivot to rationing models, priority for dialysis, pediatrics, insulin, while black market conduits proliferate. Volcanic eruptions inject not only cooling aerosols but greenhouse gases. Paradoxically, carbon dioxide released may partially offset short-term cooling a decade hence, setting the stage for a rebound spike once aerosols settle. Climate systems, like a coiled spring, may overshoot. Glaciologists note accelerated albedo feedbacks. Wider snowfields reflect sunlight, reinforcing the chill. Equatorial precipitation bands migrate, intensifying Sahel drought. Tropical cyclones diminish in frequency, but grow in raw destructive power as temperature gradients sharpen between cool land masses and warm ocean gyres. Ashfall acidifies freshwater systems. Fish kills blot lakes from the Poconos to Quebec. Forests near Albany, weighted by ash, topple in domino cascades. Their decay over subsequent seasons releases methane amid the chill. Pollinators falter when late spring flowers remain dormant. Insect populations crash, reverberating upward through food webs, songbirds, then raptors, then scavengers. On the Atlantic shelf, dimming light stunts, phytoplankton blooms, fisheries contract. Yet life, inexorably inventive, exploits new niches. Pioneer mosses colonize ash flats. Fungi metabolize volcanic minerals. Red foxes, emboldened by urban silence, din and crack subway vents. Evolution tiptoes forward. Temporary capitals arise. Federal agencies relocate to Chicago. The United Nations establishes a field headquarters in Montreal. Researchers channel wartime urgency into ash. Resistant seed strains, vertical indoor farms bathed in LED sun, new respiratory therapeutics. Architects draft resilient city blueprints, modular buildings of fiber-reinforced basalt composite, roofs pitched steeply to shed ash, triple-filtered ventilation systems. Subway networks, where rebuilt, run within vacuum-sealed tunnels ringed by ceramic insulators. Psychological support becomes its own infrastructure. National Service Corps embed trauma counselors in relief caravans. Museums curate artifacts salvaged from the lost metropolis, forging collective memory that tempers grief with continuity. Years pass, seismicity wanes. Rainwater fills the collapsed chamber, birthing a caldera lake 40 kilometers wide, rimmed by cliffs of welded tuff. Hydrothermal vents enamel shoreline stones in garlands of sulfur and cinnabar. Scientists arrive to measure, sample, and marvel. Beneath their instruments lurks a smaller magma reservoir, still restless. But geothermal gradients also gift opportunity. Turbines tap benign vents for sustainable power, feeding new settlements on the lake's safe shoulders. From catastrophe sprouts an unbidden engine of renewal. Art ever responsive, transforms ash into pigment. Painters mix volcanic gray and caldera blue. Poets record dawns where sunlit columns of aerosol paint halos around a dim star. Film directors capture evacuated avenues reclaimed by meadow and fox. Annual remembrance rituals echo across former time zones of commuter trains. A single minute of silence at 7:25 followed by cathedral bells, forged from scrap steel salvaged in the ruins. The bell's low timbre seems almost tectonic, reminding listeners of deep forces that lie beyond human schedule. Instrumentation seeded prior to the eruption yields an unprecedented dataset, crustal inflation sequences, degassing rates, aerosol radiative forcing, agroclimatic teleconnections. With grim clarity, humanity refines models predicting not only future eruptions, but also the planetary cost of unmitigated greenhouse emissions. A renaissance in monitoring ensues. Dense seismic arrays bloom in unstudied back-arc regions. Satellite constellations track ground deformation daily. Societies allocate resources for early warning networks akin to meteorological services. Slowly, the world absorbs a lesson older than cities. Geology is indifferent, yet generous, offering both fertile soils and existential tests. After 3 to 5 years, stratospheric aerosols settle. Skies brighten, average global temperatures creep upward. Agriculture in temperate latitudes rebounds, famines ease. Yet ice sheets swollen by the cold spell now preside over seas that fell by a few millimeters, briefly masking underlying trends of thermal expansion. Coastal planners, eyeing the resumption of sea level rise, juxtapose two timelines. The sudden, the gradual. They resolve that resilience must account for both. In the push to rebuild, arguments erupt: should one reconstruct on the old footprint or leave the scar as a monument? Some advocate a memorial park ringing the caldera. Others press for a Phoenix city smarter and stronger. Consensus emerges only in education. Curricula worldwide adopt the New York event case study, a cautionary canvas illustrating systemic vulnerability, cascading failure, and the potency of foresight. Drills become common in cities with dormant volcanic neighbors. Naples, Auckland, Seattle, Arequipa. And so, from the vantage of decades, the eruption beneath New York is spoken of the way our ancestors spoke of ice ages, a hinge moment in human narrative. It underscored limits, revealed interdependencies, yet also galvanized collaboration across frontiers once divided by language, politics, or profit. The earth is restless, even beneath the most unyielding metropolises. Granite can fracture, and civilization's tallest towers may crumble to dust finer than flour. Yet out of such dust rise questions, insights, and an enduring determination to adapt. May this thought experiment serve not as foreboding prophecy, but as reminder that vigilance, humility, and ingenuity remain our most reliable tools against fire from the deep or any challenge tendered by the grand and patient planet we call home.